Hello, I'm Stefan Greber, project leader for LXD, and in this video I'd like to go over what you should do to backup and restore a production LXD server. There are a few different ways to do that. It also varies between you using a cluster where you've got solutions like, well, the database itself being effectively automatically backed up thanks to cluster replication, and where you have options like distributed storage with Ceph or distributed networking with Oven to take care of all of your high availability and recovery needs. As opposed to what you may be running on a single server where you don't have any of that, and where if you were to somehow lose your boot disk or something like that, which includes your LXD database, you might end up in a pretty bad shape. There are quite a few ways to handle that in LXD, and I'm going to be going through some of those, including with examples. So the matching documentation page we have here is under production setup backups, and that's what I've got open here. It shows kind of what you should consider to backup. So the instances themselves, potentially images, if you care about those. If you're just using cached images from our own image servers, doesn't really matter. But if you produce your own, then that does matter. Information around your networks, profiles, storage volumes, etc. So you should probably figure out first what it is that really matters to you, as far as, you know, what would be really annoying to set up again, and make sure that that does get backed up for you. One of the options is to perform a full backup. So effectively, you backup every single bit of LXD data, which is either varlib LXD on distros not using the snap, or varsnap LXD varsnap LXD command LXD on those using the snap. You make a full backup of that, whether it's a tarball or using some backup systems, and then you will restore that on the system should something bad happen. That works reasonably well, especially if you're using local storage pools or using the directory storage backend, in which case all the data of the actual instances are also stored in there, and you're good. If you're using a dedicated device to run like a ZFS pool or LVM or something like that, then you're gonna need to separately make sure that this also does get backed up in a way that can be restored, so that when you restore the rest of LXD, it can still find the data that goes along with it. Another method that can be pretty convenient is if you've got a secondary server, you can use LXD using the LXD copy command to copy your instances to that other server. You can even do it including snapshots using a refresh mechanism, which will just transfer whatever has changed. That lets you have a lighter weight way of copying those instances. And because you effectively have two servers that you've always configured identically and have the same profiles and networks configured on them, you know that should something bad happen, you can just start them back up on that other machine. That other machine might not have as much in the way of like memory, disk, CPU, etc. It just needs enough to store all of the data, and should something bad happen, you can always maybe manually transfer some hardware resources from one machine to another in order to recover. Otherwise, other options are using LXC export, which lets you get a tarball of an instance. The same is true of LXC storage volume export, which does the exact same thing with a storage volume. So you get a tarball that you can then import back onto a server. You can make that quite optimized by using compression, which happens by default, but you can tweak which one you want. Or potentially by using the optimized storage option, which rather than exporting as just a bunch of files, like exporting every single file in your instances, will actually export as a binary blob. The downside of doing the optimized export is that you will need to restore it on the same storage backend. So if the server you're doing the export on is using ZFS and your target server is not using ZFS, you won't be able to import it. So it's something to keep in mind. It's got some pretty serious advantage as far as like speed and size, and also like actually encoding all the metadata if you do it as optimized. But it does come with the downside that you can't necessarily restore it on every single system. Then the page also describes how to handle data recovery. That's obviously something that you should try and avoid having to do, but LXD does have some metadata that's recorded within the instance volumes themselves. That's called the backup.yaml file. And should the LXD database be completely gone and the only thing you still have access to are the instance is the instance storage itself, you can restore from that. You can effectively use the LXD recover command, point it at the storage pool that you have in place, and it will then look at everything and import it back into LXD. It will tell you if you're missing things like projects, networks, profiles, etc., asking you to manually recreate whatever is missing, and then you'll be able to actually process the instances and get things back online. This is definitely disaster recovery. That's why the LXD recover command cannot be scripted. We've on purpose made it only interactive because it should never be scripted. If you're scripting LXD recover, you're doing something really wrong because it is a disaster recovery tool. It's a last resort type thing, not something you should be using day to day. And that's really for the main options that you have. Again, if you're using a cluster, you can probably make your cluster be HA, which avoids a lot of those issues, relying on the other remaining cluster members as a way to recover should there be an issue. If you're running standalone, you can do backups or copy your instances to another machine or export your instances regularly. And should it come to that, there's a disaster recovery tool that lets you recover in case of an issue. So let's take a quick look at how that all looks like. So here I've got a server called v1 that's got one instance running, tiny container. And I have also another server called v2 that's got a copy of that instance. So I'm not in the cluster case, but I've got two server case. And in this case, let's say we actually wipe the instance of v2. So let's just wipe it off. Okay. The way you will then do a copy is you do from the source, so A1 to V2, stateless because it's currently running, so we don't want it to try to live migrate or anything. We just want to copy its just the disk storage effectively. And then we do refresh, which is not really useful for the initial copy, but will be useful down the line. So if we do that, now it's copied, it's present on the second server. And you can then do this command as often as you want, and it will effectively get LXD to run rsync between the two to synchronize the root file system so it lines up. The same is true for snapshots. If I look at the target and we do v2a1, there's no snapshots, there's nothing on there. Now if I make a snapshot on here, okay, and I copy again with refresh, and I check on the target, now I've got a snapshot. If I delete the snapshot on the source, and I copy again, now it's gone from the target. So you can really use that command to just keep things in sync, and that way your target server has a copy of the container or VM, and should something go bad, you can go and either copy it back from there as a way to just pull back the backup, or you can just straight up use that target server as a way to recover your data. So that's the convenient way when you've got two servers. Now let's look at what it would look like to do a full backup of LXD. So what I'm going to do here is just create a tarball of LXD itself. So let's call it backup.gz. And what we want to backup is, I think it's trying to remember the syntax for nice clean tarballs. I think it's effectively that. Actually, I want to just back up the LXD directory from within var snap LXD command. I think that's what I would like to do. This is failing because wrong order, maybe. Let's try it that way. That's better. There we go. Okay, so now I've got a tarball here. If I look at at what's in there, it's got not only the LXD database and its log files and everything, but it also has all of the files from within the instance that's currently running. So we can see A1 here. So it effectively contains everything. Now, let me just stop that instance to make it a bit easier to clean things up. Okay, so I'm gonna wipe my LXD server completely and then reboot for good measure. So the result there should be that when it comes back, it will come back as a LXD server that's never been initialized effectively. So completely clean as you might get if the machine just got reinstalled effectively. Just give it a few seconds for it to reboot. Okay. So if I go and look at the state of LXD right now, it should be pretty sad. if it even starts. Yeah, it does start. Okay, so it is completely empty. There's no instance, there's nothing there. So in that kind of scenario, what you'll want to do is just completely stop LXD. Okay. Once that's done, you can go and wipe the directory, go back in there, and then extract your backup. Okay, and then snaps.lxd. Okay, check that it works, and we're back in business. So that's the easy way when you've got a comprehensive backup that contains the entirety of the LXD tree, and that also happens to contain your instance or instance data effectively all in one place. That's pretty straightforward, as you've seen. You just need to stop LXD, wipe its data directory, restore the table you've made, and you're done. All right, now let's take a look at the kind of the other approach, which is to do exports. So I can do, actually, let me just clean up this one for clarity. There we go. Let me do an export of A1. There we go. So what we got here is we've got a table for the container itself. We can see it's all under a backup directory here. And it contains an index. It contains that backup.yaml file I mentioned earlier. With that in place, if we didn't have the instance, we could just import it from its backup. And again, we're back in business. As you can see, it restored it perfectly. So it's getting the exact same IP address and everything. It's the exact same thing. It restored all of its configuration, every single bit of data. If it had snapshots, it would have restored the snapshots. Everything that's part of the container or VM will be restored that way. As mentioned, the exact same is true for storage volumes. So if I was to create a volume called foo, I can export foo. Volume export default foo. There we go. And now I get a backup.gz file here, which is for that empty volume. And if I want to delete it, then I can import it back into that pool the exact same way. And the volume is back. So you can use that as a way to export your instances and volumes, including all the snapshots and all that data, put that on offline storage, put that on like a CD-ROM or whatever you use for archival purposes, and then you'll be able to re-import that later on. So that's for the export and import mechanism. The last thing I've not showed is the disaster recovery. So let's try and make, cause a disaster effectively. A good way to cause a disaster is to wipe the LXD database. That would kind of simulate the worst case scenario for complete corruption of the LXD database, which is not something that happens very often, but could happen in some scenarios. I'm just gonna kill things and reboot the VM to again get a pretty broken state effectively after reboot. That kind of simulates a worst case scenario of, you know, a hard disk having gone bad, data corruption, that kind of thing. The LXD database is pretty reliable in that it actually records in chunks in different files, and so worst case scenario on startup, it will notice some data is missing or broken. It will just go back in time effectively by a little bit. So it's very resilient, but it's still possible, whether it's by user error or by accidentally reinstalling a machine, having forgotten to backup LXD or something like that, to end up in a case where you don't have a database, but you still have your instance data. So again, if I look at LXD now, we should be in a weird situation where there is nothing running, so no more instances at all. But if we go look at the storage on disk, even though LXD doesn't know about it, there is a storage pool here. Like, we do have a storage pool, we do have instances, we do have stuff there. LXD just doesn't know about it at all, to the point where like there's no storage pool listed. So that's where we can use LXD recover. So I want to to recover a new storage pool. The name for the storage pool is default. It asks us what the type of that storage pool was. It's a directory pool. The source, we should be able to just go with empty because it was at the normal default location. So nope, actually it does want it. Okay, so we'll give it the full location. Can basically copy paste it from what I showed earlier. Okay, and there's no special config or anything, so we can just move on. Do we want to recover anything else? Nope. All right, so it shows that the recovery process will be scanning the following storage pool, a directory storage pool at this source address. We'll be scanning for lost volumes as well, so that means it's going to be looking for custom storage volumes as well as instances. And here we go. So we can see that it detected the custom volume called foo that we created earlier, as well as the container called A1. Neither of them have snapshots, but what it did notice is that they are referencing a LXD BR0, which does not exist currently. So it can't restore it because of that. When that happens, you kind of need to just put that to the background for a little bit and go and make it happy. So in this case, we're going to be recreating the LXD BR0 bridge. Okay. And now that this is resolved, we're going to hit enter. It again shows that those two things are to be recovered. There's no more error. Do we want to go ahead? Yes. And it's been recovered. So the instance is now here, and it won't actually, so it can only restore what it finds on disk. So it does know that the instance needed that storage, network. What it doesn't know is that that network was part of the default profile. It could only see that the default profile needed to exist, and it does, so it was happy with that. So what's missing here is actually adding to the default profile the network device in this case. So if we just add that missing bit, now it should be much happier. There we go. And yeah, we're back to normal. We've got a working instance. So again, this is a disaster recovery mechanism. Definitely not something you want to very actively rely on. It's something that is probably worth testing, at least once, just to get an idea of whether it will even work for you and kind of what it looks like, what data you might need. As mentioned, it can only read what it has on disk. So when you lose the entire database, you're gonna lose some other things. You're gonna lose a bunch of profiles. You lose a bunch of network definitions. You lose a bunch of server config. It won't be able to restore any of that, and it will do its best to figure out what is missing and letting you know about it, so you can go and manually restore that one way or another. Once that's done, you get to at least get your instances back and all of their data, which tends to be what most people really care about. And that's pretty much it for LXD. How to handle effectively backups of LXD and recovery. One other thing actually that is not, I don't think it's actually mentioned on there. It's mentioned in another different page that covers the database. One thing that can be worth doing separately from doing a full backup of the database files is to backup the content of the database. It's not the most useful thing to have because it's not trivial to restore it, but it might be quite helpful to fill in some of the gaps if you need to do disaster recovery, for example. So there's a subcommand of LXD called SQL, which you can use to access both the local database. So you can do local.dump, and that dumps the SQL of the local database, which doesn't contain too much data. And more importantly, do the same thing to the global database, which does include everything else. And that includes, in this case, like we can see some amount of project configuration is here. If we go back to instances, we'll eventually see the details for the instance we're running. There we go. It's right here. So that can be pretty useful because it gets you a text representation of your database, which is a bit more easy to read through than the binary version you might include in a table. It's also pretty cheap to run that, so you can pretty easily put in like a daily script or daily backup to just dump those two things as compressed SQL files and just store them on the side as part of your daily backup routine. And with that, I think we're actually done this time on backing up and to an extent restoring LXD, the different approaches you can look at going through for that. And hopefully you never need it. That's always the thing with backups. You really very much hope that you'll never need it, but you should still do it, and you should still do some tests to make sure that you can actually recover from whatever it is that you're doing for backups. If you've got any questions about this, feel free to leave them down below in the comment section, or you can go on our community forum, and I'm going to have this documentation page linked in the description. Thanks for watching, and see you in the next one. Bye.